might have to simplify or rationalize. Here's a throwback to chapter 1. Oh. Remember chapter 1? Everybody love chapter 1. Okay, so here's the problem. Here's the problem. Now, again, focus, my friends. It's going to tell you, obviously, find the limit in the directions, if it exists, blah, 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 blah. Obviously, there's a lot of different techniques to do it. First thought, I'm like, great, it's a fraction, it's a rational function. I'm going to use direct substitution. Right away, though, I hit the wall because if I put 0 in the bottom, not quite. 0 under the line's not going to cut it. So we saw that yesterday, and I was able to do some factoring and simplifying and make it work. Well, I can't really do any factoring on the top. We can't square root out the t squared and the 9 because of addition. If it was product, that would work, but not equivalent on addition. So now we're going to throw it way back to chapter 1, and we're going to rationalize the numerator. If you remember, it's a long time ago we did chapter 1. There's a couple weirdo rationalize the numerator. Usually we do the denominator. The numerator, here is the y. Okay, so just like chapter 1,
never mind.
to rationalize the numerator, we're going to use the same expression, but I'm going to change the -3 to a +3, and you'll see why here in a minute.
Oh, I failed this section.
Oh boy. And we have to multiply the bottom, of course, by the same exact expression.
In the form of y.
Now, the y is, of course, the top's going to do some simplifying, so let's just fill this in our limit. And I'm going to multiply these together. Now, it looks crazy, but it will come out nice for us. So when you multiply two square roots together, really what happens to the square roots? They cancel. So I'm just going to have t squared plus 9. There's a projectile that came towards the front of the room. Who's got it? Jackson? What just happened, Jackson? Right now? Should have gotten Okay, moving on. Now, I'm not going to do the full FOIL on this because the middle terms will cancel out, so it's not worth us writing all of that out. Because when you do this times +3, and then, of course, when you do this guy with the -3, they're going to cancel out, so we're going to skip them. So, first outer inner, I'm on the last, of course, -3, -3. And yes, I will combine that and simplify it out in a minute. Now, the bottom's kind of a hot mess. I'm just going to fill it in. I've got my t squared. And I get the square root, t squared plus 9 plus 3, all the stuff. Plus 3. Okay, so I'm going to get rid of those 9s, of course, on the top. Let's just cross them off. And what else could you simplify out? The t squared. So I'm going to chop those off, too. So let's see what we are down to. So t squared over t squared, of course, we canceled, so we just have 1. We need a placeholder, of course, in the numerator. And then we've got, obviously, the square root, t squared, plus 9, and then plus 3. So same value of the expression, just a different form. 2 4s, 3 6, 4 8s, all the same thing, just different forms. That's what we've done. We've just put that in a different form. Now, I think my direct substitution would be a win. Because if you put 0 in here, what's 0 squared?
0.
Plus 9.
9.
Square root of 9.
3.
Plus 3.
6.
So I have 1 over 6. Done.
I did that on my head, like that was really hard to just give an applause.
Good job, Alex. Okay. So sometimes direct substitution is all of our favorites. I prefer direct substitution too, but I couldn't put 0 in for t squared right away because you'd have 0 under the line. So I had to rationalize back to chapter 1 and put it in a different form. I just like to keep writing at chapter 1. Okay, we have talked already in the past about left-hand, right-handed limits. We have talked about this. This is all in your notes, so just threw it on here again because that's what we're going to use here in a little bit. So, remember for an overall limit to exist, the left hand, the negative, the right hand, the positive, have to equal the same thing. We've seen that before. If you don't equal the same value, the overall limit does not exist. So we're going to take a look at that situation here in just a couple problems today too. So show that the limit, absolute value of x equals 0. Now, a couple different ways you can do this. I'm, of course, going to show you the graph because I like to look at the graph. and we're going to do it algebraically, just so you're prepared for both if you have to do it. So I'm not going to get crazy. You could graph this on your graphing calculator. Do you remember where absolute value is in your calculator?
Yes, math.
Math menu. I'm going to go old school and just sketch one by hand.
Sketch your graphing calculator.
Sketch the graph. Now, absolute value. I'm just thinking a little mental T-chart here. I'm not going to get too crazy. If I put 0 in for x, what's the absolute value of 0? 0. If I put 1 in for x, what's the absolute value of 1? So 1, 1. If I put 2 in for x, what's the absolute value of 2? 2, so 2, 2. Probably should try some negative numbers, I suppose. If I put negative 1 in for x, what do you get? 1. Because remember, absolute value is always that V-shaped graph. If I put negative 2 in, absolute value negative 2? 2. So that's enough to see the V. Okay, so we can look at the graph, of course, the left-handed limit. We're going to look at the right-handed limit, and then, of course, I'm going to show you algebraically, too, so you're prepared for anything. You never know what I'm going to ask you. So if we're going to get fancy here and take a look at the limit, and I'm going to put 0, negative. We're looking from the left. Okay, so from the left-hand side, I would say we are approaching 0. We're going to look from the right-hand side, so I'm going to put 0 plus. So now coming in from the right-hand side, approaching 0, we end up at 0. So next question. Does the limit exist?
Yes.
Yes, because they're equal, the left and the right-hand side, and obviously that is showing us we knew it was going to be 0. Now, just to show you, what if I asked you to do it algebraically? Alex sighs, to do it algebraically, okay? And not that you can't verify it on your graphing calculator and look at it, I mean, that's a valid backup method, but if you're going to do it algebraically, okay? So let's talk about the absolute value of x here. Are you okay back there? I'm telling you, this hour's falling apart. Pens flying, people tripping. Has Alex been singing yet?
Yes.
Okay.
Did you not hear him?
I did not. What?
Yes,
Have you been singing?
He's
No.
been singing quietly.
Okay.
Yeah, I think it's you with
I shouldn't have asked. All right, so a couple of things. So he's back there chair dancing. So, let's try to focus here. So your absolute value of x really can kick into what we call a piecewise function. Obviously, we've seen those. We're going to see one coming at you here again. So I'm going to talk about the easy part first. I'm going to talk about the right hand side of this graph. So if you put a positive number in for x, an absolute value of that, you get a positive number. So I really can just pop off the absolute value if x is greater than 0. I forgot the x. I said it. I just read it. If x, and I'm running out of room. If x is greater than 0. Now, let's talk about the left-hand side. Plus, I think about this. I'm going to put that x is less than 0 for our left-hand side. So if you put a negative number in, negative 7, what's the absolute value of negative 7? 7. So it's like you have to put another negative sign on it. So you have that double negative. So getting fancy here with our piecewise function. Or really, I look at this too to get this left-hand side. Think about your y-intercept would be 0, your slope's negative 1. Down 1, right 1, down 1, right 1, so on and so forth. So when we take a look at this and we want to do it algebraic, because I'm prepping you for the next problem, of course, prepping you for the next one. If I want to use my direct substitution, of course, well, you're going to have 0 and negative 0. Wasn't negative 0, 0? Yeah. So they both turn out to equal 0, so our limit is 0. So that's kind of the algebraic way. Keep this in the back of your head because I'm going to use it when you flip this over. And this should say prove. I don't even know what happened there. Come on, spell check in Microsoft Word. Okay, so prove that the limit does not exist. Now notice it's a little different than our last function because I also have that denominator over x. Now, I can't go direct substitution right now. Because if you put 0 in for x, you're going to have 0 over 0, which is weird. We can't do it. So we're going to look at the left-handed and the right-handed limit. So doesn't matter which one we do first. I'm just going to set it up there as the right hand. We'll do the left hand over here. Okay. So our function, so we got x over x. That's a sloppy x. Okay. So the right-handed one, if you ask me, I think is a little bit easier because we've already talked about this. If you put a positive number in the right-hand side, absolute value of a positive number is just that value. We don't need the positive, we don't need the symbols. I can take them off. And really I could write that simpler. What's x over x really? Uno. Working on our Spanish, I guess, today. And now we can use one of our special limit cases from yesterday. Not that you have to know that. But when you just have a constant number, what's the limit?
1.
So I'm going to circle that. Now I'm going to do kind of a similar thing over here for the left-handed side. Now we just talked about this. If you put a negative number in and do the absolute value, the sign switches. So you need a negative on it. So I'm going to write this out nice and pretty. Limit 0. So really I'm going to have -1 here. And again, that's your special case of your special limit laws. Your constant, you just end up with that number. So the question is, remember the directions, show it does not exist. Didn't I just do that? They don't equal each other. I got +1, I got -1. We know when the left and the right hands do not equal the same thing, you overall have a does not exist. All right, are we ready for the final one?
Yep.
I'm kind of sad this is all we have today. I'm a little depressed about it. Okay, determine whether it exists. So again, we have to check both sides, the left and the right. I'm going to start, let's just left, I guess, first. So I'm going to make this I put the negative on for the left-hand side. Now we're going to take a look at this here for a quick sec. You have your two possible situations to plug this value into. You got to look at these inequalities at the back. Left. So am I going to put it in the top one or the bottom one? Bottom. Less than 4. We're on the left-hand side of 4. I'm going to use the bottom one. Now this is a polynomial function. Polynomial, sum of one or more monomials. I can use my direct substitution. So put a 4 in there. So it's 8 minus 2 times 4. Why are they harassing you, Kyle? Quick, Alex, what's 8 minus 2 times 4?
24.
Go again.
0.
Okay. Lord help us all. All right, let's do the positive side. So I'm going to put the plus on the 4 just for our positive side. Now again, we just have to choose wisely here. So positive side, we're looking on the right side of 4. So I'm going to use the top expression now. So I'm going to use the square root of x minus 4. Well, I can use direct substitution on that, put 4 in there. What's the square root of 4 minus 4? 0. Square root of 0, 0. So next question, does our limit exist?
C.
Yes, because we got the same values on the left and the right. And what is your final answer, obviously?
0.
0.
0.
Got it.
Alex.
All right. Any questions on that?
Where did it go?
Besides.